If you have looked at any data science job posting, you'll realize that there is one skill which pretty much every data science job asks for, and that is Pandas. And that is for good reason, because Pandas is hands down the most powerful and the most popular library for working in data with Python. If you are serious about learning data science, you have to learn Pandas. I've been using Pandas on pretty much everyday basis for the last 10 years. And what I've realized is that you don't need to learn everything about it. You just need to learn the right things. So in this video, I'm going to teach 80% of what you'll actually need in Pandas in under 15 minutes. If you follow along, by the end of this video, you'll be able to know how you can load the data in Pandas, clean it up, manipulate it, and actually get stuff done. So let's jump right in. So the very first thing you need is you need a setup where you can run Pandas commands. Now you can install Jupyter Notebook or Anaconda in your local, but the very convenient and fast thing to do is just go on Google Colab and start writing your Pandas code. It is absolutely free and very convenient. So that's what I'm going to show in this video. So let's go to collab.research.google.com. And once you are here, you would see a page like this. I've already created one notebook with the name of Pandas, but you can create a new one by clicking here. Once you click here, it will create a brand new Jupyter Notebook for you, which you can use to start writing your code. So let's first come right here and rename our notebook. So I'll say Pandas notebook. And then here we can start writing our first line of code. If you're absolutely new to Google Colab, it'll take you a couple of minutes to get yourself familiarized. But the most important things you need to know is that these are the cells where you write the code. For example, print 2. And then you can create as many cells as you want. And then if you click on this play button, then this runs the code. For example, if I click here, it'll take some time, but then it'll print the result too. Now, in order to check if Pandas library is already there for you to use, you can check it by running import pandas command, and let's run it. Did not give us any error, which means that Pandas is available for you to use. A very common way you would see when people are importing Pandas is that they rename it as PD, which is just a convenient and short name for Pandas. So once we do that, now Pandas is available for us to use as PD. So the very first thing we have to do is that we have to import some data so that we could do some data manipulation. And for that, we are going to come on this website. On Kaggle, there are plenty of free datasets available. This one is a very popular dataset where people analyze customer shopping habits. It is a very small toy dataset for you to play with. It has a bunch of columns which are related to person. For example, their income, their marital status, their education, etc. Then there are some products which these people have bought, and then if there was some promotion running or not. So we are going to use this data set. I've already downloaded it by clicking here. So I'm going to go in my Jupyter Notebook and I'm going to import this data set into Pandas. So if you go into Jupyter Notebook sidebar, here you can see that you can add files here. Let me upload my file. It is just giving a warning that the runtime files will be deleted once the session is over. So if you want to store it permanently, you can then connect your Google Drive with this, and then these files can stay there forever because they will be on your local drive. Okay, so now we have this marketing_campaign.csv data available. Let's load it up into Pandas data frame. Again, a very common convention to use is that for Pandas data frame, we name it as df, and then we call Pandas, which we have renamed as pd dot read CSV, because we are reading CSV here. You can also read Excel, you can also read JSON and many other formats. But here, since our data is in CSV and the data name is marketingcampaign.csv. So let's see if this code runs. It ran without a problem. So now it has created a Pandas data frame and loaded all the data into it. You would be hearing two terms very frequently. One is Pandas series, and the other one is Pandas data frames. So let me very intuitively explain what they mean. Data frame is basically a sheet. It is very similar to an Excel table. It has rows and it has columns. Whereas Pandas series is just one column and one series. You would find online very complicated explanations for these, but that's essentially what it means. Data frame is a table and series is a column. So now this data frame has all the data from this marketing campaign.csv. And how can we look at it? You have a bunch of very handy commands available. The one I love the most is that you can just do df and then head. So this will give you the top 5 rows. And what we can see here is that the data is all jumbled because unlike common CSVs, this is not comma separated files. Instead, it is tab separated files. So we'll just go into the reading definition. And here I'll tell it that the separator here is tab. Okay, let me rerun the cells again. And now we can see that we have loaded the first 5 rows and it has 29 columns and we can see all the data here. If you want some other overview of the data, there are 2 other popular commands available for you. One is dataframe.info. It will give you a high level information on what are the columns available, how many non-null columns are there, what is their column type, etc. And another one is df.describe. It'll describe for you, especially for the numeric columns, that what is the mean value, what is the count, what is the standard deviation, what is the 25th percentile maximum. All those statistics are available for you to quickly review within a matter of seconds. Okay, so now we have loaded the data. We have had a very quick look at it. Now let's get into looking into the specifics of the data. So I want to select some columns. If I want to look at a single column, I can just write the data frame name, and then within 2 brackets, I have to put in the column name. For example, if I'm just trying to look at education field here, then I can just run it like this. It will give me all the data in the education column. If I want to look at more than one, for example, if I also want to look at income, then I can add it here. I can look at income and education columns. Now, if we want to take it one step further and we want to see how we can filter data based on different criteria we define, then the logic for that is also very simple. You just write the data frame name, df in this case. You have these brackets, and then you can mention the column name you want. If I want to look at people who are making more than $80,000, then I can define the criteria here as income and then greater than 80,000. And if I hit enter, now I can see all the people who are making more than $80,000, and you can verify it from the income column here. And let's say if I don't want to look at the data set, I can just append next to it these column names which I have previously added. So if I just copy this and bring it here and run it, and now it is showing me education and income columns for people where the income is greater than $80,000. And this is how simple it is. We have applied the filters, we have selected the columns we wanted to look at. And if there is more than one filtering criteria we want to apply, it's also very simple. I just come here and add a bracket around it, and then add either an and sign or sign depending on the logic. So let's say if I come here and then I want to look at all the people who are making more than $80,000 and their marital status is married. Marital status equal to married. I forgot to add the double equals, so that's why it's doing another. Let me add that here. And then now we can see that these are all the people who are married and who are making more than $80,000. In the list of selected columns, let me also add marital status, so I can also look at that column. So now you can see all the people who are married, making more than $80,000, what does their data look like? And by narrowing down the list of columns you want to look at, you can also see how fast you can look at the data and how easy and intuitive the commands are. Now, let's say if there are some null values, we can also get a count of it. And the command for that is very simple. We just say df.isNull, and then I can just get a sum of it. And here I can see what is the count of null values in each of the columns. I can see the only column which has null values is the column of income. And this could be a problem if you are later trying to run some predictive models. So for that, we have 2 popular options. One is that we just do drop the rows which have null values. The other one is fill NA. And this lets you fill any null value with a value you provide. Now, what if you want to add some new features into your data? You can create new columns based on some logic. So I see here that there is a year birth column available. What if I want to create the age column based on this information? So for the logic for that is very simple. We'll just say for data frame, we're trying to add another column, age, and how it will be created. We'll take from this very data frame the column of, let me copy the column name, year birth. And then let me just create a very basic logic. So let's say 25 minus this here, and this should create a column for us. So let's look if the logic in this actually worked. So let me look at year birth column and also age column to see that if it calculated correctly. 1954, 71, yeah, that's correct. 8144. So yeah, this is working. And now if you look at the whole data frame, let me do df head again. You can see that instead of 29, now it has 30 rows, and it added the column of age towards the very end. Okay, so now we have looked at how can we load the data, how can we look at some columns, how can we filter the data, and how can we create new columns based on add-in logic which we have provided. The next most powerful thing to learn is that how do you do group by operations in Pandas. Group by is basically split, apply, and then combine method, where we try to first split the data based on certain logic, then we apply some aggregation function to aggregate. Let me show you why it matters. So let's say if we want to see that does the education level of a person impact on how much wine they buy. If we are trying to answer this question, then we need to first group people by their education level. Then we have to see how much wine they are buying on average. In Pandas, you can do it very quickly. So we'll just name our data frame, which is df. Then we'll say, okay, we want to group people by, and in this case, it is education. And then the thing we want to look at is how much wines they have bought. And we wanted to look at the mean value of it. So just by this simple line of command, we can see that basic people are buying about 7, graduation 284, masters more, PhD even more. So this clearly tells us that more educated people are buying more wine, maybe because they are earning more. And the command for this is very simple. You start with the data frame name, then what are the things you want to group by, and then what are the columns you want to look at, and then how do you want to aggregate the data. And it could be mean, it could be count, it could be if you want to look at the minimum value. For these categories, you can look at that. If you want to look at maximum value, it gives you multiple options to look at that aggregated data. You can also do a group by more than one thing. For example, if I want to say group by education and then marital status, I can just add that column here. And now it will tell me per education and marital status combination, what is the maximum they have spent. And if I do mean here, it will tell me what was the mean value. Now, these are the things which are very difficult to do in Excel. And in Pandas, you can see that you can do it within minutes. Now, the last thing which I want to briefly touch on is that Pandas also enable you to do some very good visualizations within a matter of seconds. So let's go back to our original command of we want to look at how much people are spending per each education bucket on wines, M capital, and then what is the mean value for it. So this gives me a table. What if I want to plot it? I just add to it plot, and let's see what it creates. So it has created a line graph for it, but I can tell it it should be a bar chart. And now we have a bar chart. And lastly, if you want to save this new data set which you have created by adding more columns or applying different filtration and removing null values, then you can just come here and just as easily as you read it by doing df.readCSV. In this case, we're going to say df.toCSV because we want to provide the format. And then I'll say new marketing campaign.csv. And the moment I hit enter, you can see a new file got created here, and that's the new file which is a result of all this analysis. So I hope this was a very quick and easy to understand overview where you saw how you can load the data into Pandas data frame. You can look at certain columns, you can apply different filters, you can do group by to find different data patterns, and then you can visualize the data very easily and then save the new file in whatever format you want. These are the things which you would be doing 80% of the time when you are dealing with Pandas. And if you have nailed it down, then you, my friend, can now say that you know Pandas and you can actually start using it for the next project you are working on. I hope you like the content of this video. Thank you so much for watching.